So pull out your calculators. We're going to solve today's problems using the TMV solver that Justin talked about last Friday. So with your calculator on, push the apps button. So push apps and then finance and then TVM solver. So for this TVM solver, the trickiest thing you're going to have to deal with today is N, capital N. In the compound interest formula we used, lowercase n was the number of compounds per year. In this case, N has nothing to do with compounds. It has everything to do with the total number of payments, payment periods. The trouble is, a lot of the time, you don't make any payments. So you have to pretend that you're making $0 payments a certain number of times per year. So I is the interest rate. That's easy. PV stands for present value. That's how much you have right now. Okay? PMT stands for payments. If you put $10 in the bank and leave it there for 20 years, your payments are going to be zero. You didn't put any money in, any extra money in. But you still have to have payment periods. Okay, we'll talk about that in a second. So FV is future value, and something here has to be negative. So if I pay $10 into a bank account, I just lost 10 bucks. But when it grows to $15 over the course of 6 years, then I gain 15, which means I made 5 bucks, right? So if your payments are negative, then your future value will be positive. So something is going to be negative no matter what you do. So remember that, because later you're going to get an error on your calculator and you're going to say, why? It's because nothing is negative. P/Y stands for payments per year. So if you put $10 in an account for 5 years and you make no payments, you have to pretend as though you're making $0 payments. So you could say you're making one $0 payment per year. So you would put a 1. Well, if you make one $0 payment per year for 5 years, then your capital N is going to be 5. Right? If you switch your P/Y to 2 $0 payments per year, then your capital N value is going to jump to 10. And that's not going to affect the outcome. So your P/Y and your N are tied together. The tricky thing is, as soon as you program a P/Y, it automatically changes your C/Y, which is the compounds per year. So a lot of people make a mistake because they'll go in and change their P/Y and then not realize that that changed their compounds per year. So if we look at this worksheet, Jim makes a deposit of $12,000 in a bank. The deposit is to earn interest annually at the rate of 9%. Yeah, I typed this and I used a bunch of periods when I should have used question marks, so I did a find replace, so I didn't have to search them all. And I accidentally replaced one that shouldn't have been. So anyway, okay, number 1. How much will Jim have at the end of 7 years if the interest is compounded yearly? So how many payments is he going to make? Well, the initial amount does not count as a payment. So after the $12,000, how many payments is he going to make? None. But we have to have payment periods. So let's say he makes one $0 payment per year. How many total payments is he going to make over the life of this account? 1 per year for 7 years. So we're going to change this to be 7. Interest rate is 9. Present value, principal value, 12,000. How big are his payments? He doesn't make any, so 0. Future value is unknown. That's what we're going to solve for. How many payments per year did we decide? 1. Now, what if I put a 2 here? What would my capital N be? 14. And if I change this to 2 and n to 14, it will not affect the problem. And you'll notice that the compounds per year automatically jump to 1, but it needs to be 1 because it says compounded yearly. So we go up to FV. Oops. Alpha solve. And that's negative. So if the original investment would have been negative, then the future value would be positive. That's always going to happen. So he will have $21,936. Okay, number 2. How much more money will he make in the 7th year period if the interest is compounded daily? What do I need to change? I'm going to go down to compounds. I'm going to change it to 365, and I'm going to resolve for FV. But that's not the answer. So the cool thing about this is I don't have to exit out to make calculations. I can just add to this. So if I want to go all the way to the right, that's going to take some time. If you push second right, it'll jump all the way to the right. Second left will jump all the way to the left. What will second up do? It makes your screen darker. Second down makes your screen lighter. So I don't know if you knew that. So I'm going to take this and add, what was it, 21,000. Please tell me 936.46. And I hit enter. So it's a difference of $593.11. So it's the same amount of money being put in, same time, same interest rate, but when it's compounded daily, you earn more interest than if it's compounded yearly. Okay? And number, what are we on, 3? What is the effective yield on the account if it's compounded hourly? Remind me what effective yield means. Right, if I told you you gain 10%, that number is a little misleading. If it's compounded once a year, you actually earn 10%. But if it's compounded more than once a year, you earn a little bit more than 10%. And instead of telling you what the compound is, because there are other factors that we're not taking into account, like what day of the month you pay, there are lots of things. So what we say is, this is the APR, APR, which is the annual percentage rate, and the APY, the annual percentage yield, is dependent upon how often it's compounded. So what we need to do is figure out how much money there will be at the end of the year, divide it by how much you started with, and that will tell us the APY. So hourly, I'm going to change my compounds per year, 365 times 24. And then I'm going to recalculate the future value, which was a little bit higher than it was before. What do I want to do to the future value? Divide it by 12,000. So second right divided by 12,000. And I get this number. Oops. I did something wrong, didn't I? So divide by 12,000. What am I doing wrong? Oh, this is 7 years. Sorry. We don't want 7 years, right? What do we want? 1 year. So now I recalculate, and I divide that by 12,000. And I get this number, 1.094. What does that number represent? Well, it's kind of the yield. So this is the old m value in our y equals bm to the x. So if you have 1.094 of what you used to have, how much did you increase? 9.4%. So we have to subtract 1 from this and just focus on that number. So the annual percentage yield is 9.4%. The APR is 9, but if you compound hourly, your yield is 9.4, which is good. So number 4, what is the effective yield on the account if the interest is compounded semi-annually? What do I need to change? Change the compounds to 2, recalculate the FV, divide that number by 12,000. So what is that APY? 9.2%. What if you compounded it yearly? What would the APY equal? Don't bother doing it. It's going to be 9. If you only compound once, then the APY is equal to the APR in every case. Now, we started this with $12,000. Is the APY bigger, smaller, if I would have only invested $10? It's the same. So when you're calculating APRs and APYs, the amount of money you put in has no bearing. So if I don't tell you how much it is, if I say 6% interest compounded weekly, what's the APY? What value should you use for your PV? It doesn't matter. You could use $1, you could use $1 million, it doesn't matter. The APY will be the same no matter what number you pick, because you'll just divide it by whatever number you pick. Okay. No, you wouldn't. That's a good point. If you put $1 in, then you wouldn't need to divide it. You would actually get the APY. You'd still have to subtract off 1 in the end, but you're right, it would be the answer. Number 5. Compounded daily. How much will Jim have at the end of 30 years? So we need to change our compounds to 365, and I need to change my n value. What is my n going to be? 30 times whatever my payment frequency is. So my payment frequency is 1, so I change that to 30. Calculate the FV. So 100 and... Yes, it's still the same interest rate, same principal. Okay. So now he's going to make a $20 payment each month. So we need to look at the frequency. How frequently is he going to make payments? Yes, for the same 30 years. So how often is his payment? Well, so my payment will be 20, so I'm going to change this to 20. And then how many payments per year? 12, because it said monthly. So I change this to 12. And now if I change payments per year to 12, how do I calculate N? 12 payments per year for 30 years, and I can just type in 12 times 30, and I get 360. Now I'll calculate the future value. Oh, and see when I put payments for year 12, my compound changes, so make sure you fix that, or else you'll be a little bit low. So it's alpha enter. Yeah, that won't work. So he made a little bit more money. What, $400,000? So that's nice. You having trouble there, Nate? That is number 5A. Yes. Well, I would stop at 0.76. Okay? So now we want to change the $20 payment to a $200 payment. And see what that does. Wow. Mm-hmm. Oh, because you have this as a negative. Yeah. So what you were doing, Brindler, was paying off a loan. So when these are opposite, when the payment and the principal value are opposites, you're paying off a loan. But if they're the same sign, then you're paying toward more. So you were paying off a loan. That's why it was different. Okay. So um, number 6. So let's say that he doesn't make any payments. Change that to 0. And he's going to do 40 years instead of 30 years. So my N now becomes 480. I could make my N 40, but then I would have to change not the compound, the payments per year. And I want to keep that because the next two problems have 12 payments per year. So the N and the P slash Y are flexible as long as the payment is 0. If the payment is something other than 0, then they have to be right. Okay, so watch this. Oh, wrong. So he went from 173,000 at the end of 30 years to 438,000 at the end of 40 years. So that last 10 years more than doubled his money. So that's nice. Okay, so part A wants a $20 payment, 12 times a year for 40 years. So in 5B, he spent $200 a month for 30 years. In 6A, he spent $20 a month for 40 years. Which one was cheaper for him? Which one did he spend less money on? No way. Well, I mean, how much did he put in? Paying $20 a month for 40 years is a lot cheaper than paying 200 for 30 years. But they ended up with the same amount of money. So $20 and 10 years is worth $200 and negative 10 years with this interest rate. Okay, 6C, don't worry about it. That's a dumb problem. Cross it off. Yeah? Yeah, where you been? Oh. And there are some other C's later on that are just like this. Don't do them. It's a pain. Well, not all the C's, but all the C's that look like that. Okay, number 7. Suppose when you turn 18, you decide you want to make $1 million by the time you turn 58. You find an investment that will give you 8% weekly. How much would you need to invest each month to reach this goal? So, what is your interest rate? 8%. Okay, what is your present value? We do know how much you turn 18, how much is already there? None. Okay, what is your payment? We're going to solve for payment. How much do you hope to have at the end? $1 million. That's 6 zeros. How many payments per year are you going to make? So it says, how much would you need to invest each month? So 12. How often is this particular account going to be compounded? Once a week, so 52, and it's actually like 52.5, but the difference between 52 and 52.5 is extremely small, so we're not going to worry about it. So we'll put 52, and how many total payments are you going to make? So from 18 to 58 is 40 years, 12 per year, 480. It's already set up. So I want to solve for payment. Oh, I pushed the wrong button again. So if you're 18 and you want to retire with $1 million at the time you're 58, and if you put it in the stock market, it generally will gain 8% if you spread it out in the stock market. So it only is going to cost you $284 a month. Yes. Yeah, and yours is a little bit different. Let me see it. 480. Yeah, because it's 40 times 12. So, which, this one? Oh, I see. Yeah. Anybody else having trouble with that? Okay, next one. Determine you can save 200 a month. So your payment is 200. What interest rate would you need compounded daily to have $1,000 after 4 years? So what's your future value going to be? It's actually 10,000. I read that wrong. 10,000 payments per year. 12 compounded daily 365. So how many payments are there going to be? Four years, 12 payments per year. 12 times 4 is 48. And what am I solving for? Interest rate, and I get error. Why did I get an error? Why did it give me an error? What's wrong? I need a negative on one side or the other. So it doesn't matter if my payment's negative or if my future value is negative. Either way, it will give me 2.07%. Now, percentages are very delicate. So the difference between 2% and 2.07% is really large. No, you don't minus 1 here. This one actually found the real percentage. Yeah. So the difference between 2% and 2.07 is really small in numbers, but as far as calculating interest, it's a big difference. I mean, if you can shave 1/100% off your home loan, you'll save $1,000. So it's a big deal. Okay, number 9. What is the initial amount needed to reach 500 after 6 years in an account that earns 11% compounded semi-annually? So interest rate is 11. PV equals we don't know. That's what we're looking for. Payment 0. There's an initial amount, but no payments after that. Future value, so 500. Payments per year. Well, it doesn't matter, right? Because our payment value is 0. So you can put as many payments in as you want, but it will affect your N. So whenever my payment is 0, I usually put in 1. How often is it compounded? Semi-annually would be 2. So if I put my payments per year as 1, then what is my N value going to be? 6 years, so I'm going to put 6. If your payment value was 2, or sorry, if your payments per year was 2, then you would put a 12 up there. And I'm solving for present value. So it would cost you $262.99 right now, and over 6 years you would almost double that. That'd be worth it, especially if you had like $20,000. Okay, number 10. If you buy a house that costs $150,000 and the loan is for 30 years at 6% compounded daily, what will your monthly payments be? So, my interest rate is 6. My present value would be, well, you can put just 150,000 and then the payments will be negative. So we skip payments. What is my future value going to be? Hopefully it's 0. That's the goal, is to pay it off, right? How many payments are you going to make per year? It asks what your monthly payment will be. So payments per year is 12. How often is it compounded? Daily, so 365. I need to change one more thing. The end value is going to be 12 payments for 30 years. So 12 times 30 is 360. And then I solve for payment. So your payment for that house would be $90.72. $900.72, sorry. That would be really nice. Okay. The second question on part 10 says, what if you shop around and you find a 4.5% interest? How is that going to change your payment? So $760.75. And just so you know, so let's figure out how much that house costs. The first one was $900.72 times 360 payments. Ouch. At 6% for 30 years, you're going to more than double the value of the house. What was the other one? 760.75 times 360. So if you drop the interest rate, that's going to save you $50,000. So let's say you're driving down the road one day, you've grown up, you have a job, you're married, you want to buy a house, and you see a bank that says, hey, we have a great rate, 4.5%. You get excited, you go in there, and when you show up, they say, let me see your social security number. They look up your credit score, and you've been a bad person. You haven't paid your credit card bills on time, you have other loans with late payments, and you have a bad credit score. The bank says, great, we'll still loan you the money, but you don't qualify for 4.5%, we'll charge you 6. Because you have bad credit, that house is going to cost you $50,000 more than it would cost me because I have good credit. That kind of stinks, right? If your credit's bad enough, the bank might say, no, I'm not going to give you a loan. Let's say when you're 18, you get a credit card bill, or you get a credit card for maybe $500 maximum, and you ruin your credit with that credit card, and then you go to get your own phone plan because you don't want to be on your parents' phone plan anymore, and Verizon says, yeah, we'll give you a phone, but because your credit's so bad, you need to make a $700 down payment. And we'll keep that until your credit score comes up, and then maybe we'll give it back. But if you go late on your payments, then we'll pull from that money to pay your payments because they just don't trust you. So the free iPhone that you'd get for signing up would cost you $700. And in theory, you'll get it back in the end, but it kind of depends on how things work. So what if you have a good credit score and we get the 4.5%, and I don't want to spend 273,000? I'm willing to put an extra $100 in. So this is 10B. So if I go back in, so I want to pay, instead of 760, I'm going to pay 860. So change that to 8. How am I going to figure out how long that's going to take? What am I going to solve for? No, because the final value is still going to be 0. I want to know how long it takes. The only thing here that deals with time is n. So I'm going to go solve for n. And it gives me 283.56. What does that number mean? That's how many payments you're going to make. So if you pay an extra $100, instead of 360 months, it's going to take you 283.56. So 283.56, divide that by 12. So instead of being done in 30 years, you're going to be done in 23.63 years, which means you saved 6.4 years. And let's figure out how much money. If I make 283.56 payments times, what was it, 860.75? So that house is now going to cost me 244,000 instead of 273,000. So by getting the better rate and paying an extra $100, we saved almost $100,000. Well, not quite, more like $80,000. And we shaved 6.5 years off the loan. So that $860 payment you usually make, at the end, you get to keep that money. So that's nice. All right. There is one more mistake. Look at number 13. Number 13 does not have a loan length on it. So we're going to set number 13 at 5 years. Okay? So your assignment today for the rest of the class and tonight is just to finish the second page. Not the third page, just the second page. And I do have the answers ready to go, I think. Somewhere in here. Let's see if I can find them. No. There they are. Those are kind of fuzzy. Would you rather have me? Is that better? You want them skinny and fuzzy or small and not as fuzzy? Okay, so I'll leave it there. Good luck.